Hello students, good time to all. I am Chandan Kumar Pradhan. Welcome to your YouTube channel Chandan Physics. In this video, we are going to discuss relativistic Doppler effect. Let's begin. What is Doppler effect? The apparent frequency of light measured due to the relative motion of source of light and the observer is known as Doppler effect. And this phenomenon is named as Doppler effect by the scientist Christian Doppler, who formulated the principles behind the effect in 1842 in connection with atomic spectroscopy. So, in his name, it was named as Doppler effect. Now, we have to study what should be the relativistic Doppler effect. Let us consider two inertial frame of reference. One is S frame and another one is S dash frame. S frame is at rest and S dash frame is at a velocity v, which is in the uniform velocity motion along the positive direction of x axis. Let a plane monochromatic light wave of unit amplitude be emitted from a source at the origin of S dash frame. The rays are x dash y dash plane making an angle theta dash with x dash axis. Again I repeat, a plane of monochromatic light wave of unit amplitude be emitted from a source at the origin of S dash frame. That's why the rays are in x dash y dash plane making an angle theta dash with x dash axis. That's why we introduce the equation that represents light wave in S dash frame. The equation which represents light wave in S dash frame is given by cos 2 pi x dash cos theta dash plus y dash sin theta dash divided by lambda dash minus nu dash t dash. Take equation number 1. Whereas amplitude is unit, since it's a wave, that is some amplitude cos the term, but here the amplitude is unit, only the cos term exists, and nu be the frequency, lambda be the wavelength. Again, that light wave in S frame, the corresponding equation is given as, that is cos 2 pi x cos theta plus y sin theta divided by lambda minus nu t. That is equation number 2, where lambda dash and lambda, that is the wavelength in S dash frame, that is the wavelength in S frame. Again, nu dash and nu, that is the frequency in S dash frame, that is the frequency in S frame. Here we write lambda is the wavelength in S frame, nu is the frequency of that of light wave in S frame. Similarly, here also we write lambda dash is the wavelength in S dash frame, and nu dash is the frequency in S dash frame. And we know a relation we know that lambda dash mu dash is equal to lambda nu is equal to c, that is the speed of light, which is same for each observer, that is constant. Again, from Lorentz transformations, x dash is equal to gamma x minus vt, y dash is equal to y, since the motion is along x direction, z dash is equal to z, t dash is equal to gamma of t minus vx divided by c square, where gamma is equal to 1 by 1 minus b square by c square square root. Now we put these transformations in that of equation 1. That's why equation 1 becomes equation 1. Therefore, equation 1 becomes cos 2 pi gamma of x minus vt cos theta dash plus y sin theta dash divided by lambda dash minus nu dash gamma t minus Vx by c square is equal to, we have to simplify that one, that is cos 2 pi, that is expanding that one, gamma x cos theta dash by lambda dash minus gamma v t cos theta dash by lambda dash plus y sin theta dash by lambda dash minus the term nu dash gamma t plus nu dash gamma Vx by c square is equal to cos of 2 pi, that is gamma x cos theta dash by lambda dash plus nu dash this term gamma Vx by c square plus y sin theta dash by lambda dash minus gamma v t cos theta dash by lambda dash minus nu dash gamma t. Now we put in place of gamma dash, now we put in place of nu dash, that is c by lambda dash, as c is equal to multiplication of nu dash and lambda dash. Here we put cos 2 pi of gamma x cos theta dash by sigma dash, lambda dash plus gamma c by lambda dash. Here we put in place of nu dash, that is c by lambda dash, Vx by c square plus y sin theta dash by lambda dash minus gamma Vt cos theta dash. In place of lambda dash we can write, that is nu by c dash, that is nu dash c dash minus nu dash gamma t is equal to cos 2 pi of x gamma, taking common, here we find, that is cos theta dash plus v by c divided by lambda dash. We take these two terms plus y sin theta dash by lambda dash minus nu dash gamma t, taking as common, we have 1 plus v by c cos theta dash is equal to cos 2 pi, rearranging, that is x gamma cos theta dash plus v by c plus y sin theta dash divided by lambda dash from these two terms minus gamma dash sigma t, sorry, nu dash sigma t 1 plus v by c cos theta dash. Why? This is equation number 3. Why we solve like this? Look here, from equation number 2 and from equation number 3, these two equations are very similar. Cos 2 pi, this is the term like x cos theta plus y sin theta by lambda minus nu t. These two terms are very similar to each other. Therefore, comparing equation 2 and 3, comparing equation 2 and 3, it must be identical, because it must be identical because both represent same wave in S frame. Now we comparing the coefficients of x, y, z and t in these two equations. In two equation we have here the coefficient of x, that is gamma of cos theta dash plus v by c. Here the coefficient of x, that is cos theta by lambda, that is cos theta by lambda is equal to gamma of cos theta dash plus v by c divided by lambda dash. Again equating the coefficient of y from equation 2 and 3, that is sin theta by lambda is equal to sin theta dash by lambda dash. Again the coefficient of time, the coefficient of t, since there will be no such term, the coefficient of z is 0, then the coefficient of time t, that is nu is equal to nu dash gamma 1 plus v by c cos theta dash. These are equation number 4, equation number 5 and equation number 6. Now the inverse relation for frequency is given by, that is nu dash is equal to nu of 1 minus v by c cos theta of nu. This is the transformation of frequency, this is the inverse transformation of that frequency, equation number 7. Here we use the value of this is sigma. Here we use the value of sigma, that's why that equation is written as, or we can write here nu dash is equal to nu of 1 minus v by c cos theta divided by 1 minus v square by c square square root, or nu is equal to nu dash of 1 minus v by c cos theta, nu dash 1 minus v by c cos theta divided by its constant term 1 minus v square by c square square root. This equation, which is known as equation for relativistic Doppler effect, that is nu is equal to nu dash 1 minus v by c cos theta divided by 1 minus v square by c square square root. Sorry, okay, that's not correct. Sorry, when we take nu, here I write, when you take nu, that is nu dash 1 minus v square by c square square root divided by 1 minus v by c cos theta. That equation, nu is equal to nu dash 1 minus v square by c square square root divided by 1 minus v by c cos theta. Since we take nu here, the term will be multiplied by. This is known as the equation for relativistic Doppler effect. Now we have to study its cases of Doppler's effect. Since there are two types of Doppler effect, one is longitudinal Doppler effect and another one is transverse Doppler effect. So in which type of Doppler effects we found the relativistic Doppler effect? Okay, there are various conditions like longitudinal Doppler effects. Longitudinal Doppler effect. We consider its three cases. Let case 1, when theta is equal to 0 degree. That means the source and observer move towards one another, then we put theta is equal to 0 degree in that of equation number 8. Therefore nu is equal to, that the frequency, it is nu dash 1 minus v square by c square square root divided by 1 minus v by c cos 0 is equal to 1, that is nu dash 1 minus v square by c square square root divided by 1 minus v by c. 1 cancelled out, and only the term exists as nu dash c square by v square square root divided by c minus v, or nu is equal to, here nu dash c square minus v square, that is c plus v whole into c minus v divided by c minus v, cancel out, or nu is equal to nu dash, that is c plus v divided by c minus v square root. Let us take equation number 9. This is the case 1, when theta is equal to 0 degree. Case 2, when theta is equal to 180 degree. 180 degree in the sense the source and observer move away from one another. Here the source and observer in case number 1 are moved towards one another. but in theta is equal to 180 degree, the source and observer move away from one another. Therefore, nu is equal to nu dash 1 minus v square by c square square root divided by cos 180 degree 1 minus v by c cos 180 degree, that is minus 1, that is nu dash 1 minus v square by c square square root divided by 1 plus v by c. Here nu is equal to nu dash, that is c square minus v square square root divided by c plus v, or nu is equal to nu dash c square minus v square, that is c plus v whole into c minus v square root divided by c plus v. 1 c plus v cancelled out, or nu is equal to nu dash, that is c minus v divided by c plus v square root. That is equation number 10. This is longitudinal Doppler's effect conditions when theta is equal to 0 degree and theta is equal to 180 degree. Another types of Doppler effect, that is transverse Doppler effect. Transverse Doppler effect. Here theta is equal to pi by 2. When theta is equal to pi by 2, that means the source and observer move at right angles to each other. Then equation changes to nu is equal to nu dash 1 minus v square by c square square root divided by 1 minus v by c cos pi by 2. Cos pi by 2 is equal to 0. Therefore, nu is equal to nu dash 1 minus v square by c square square root. Here this phenomenon is called transverse Doppler effect and is purely relative since it contains the relativity constant term and has no classical analog, that is the transverse Doppler effect is not observed in sound wave. So with the help of this video lecture we understand what is relativistic Doppler effect. We proceed mathematically and finally derive that is the equation for relativistic Doppler effect. Since Doppler effect has two conditions, one is longitudinal Doppler effect and another one is transverse Doppler effect. Longitudinal Doppler effect, two cases, theta is equal to 0 degree and theta is equal to 180 degree. The frequency, here the frequency. In transverse Doppler effect, that is the frequency. This one is the purely relativistic. That is transverse Doppler effect is not observed in case of sound wave. So with this useful and informative notes, let me wind up this session. Thank you.